Okay, so we're wrapping up chapter 9 with section 9.6, solving right triangles. And so some things we just have to remember is that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Ooh, look at that. There we go. And tangent is opposite over adjacent. Okay? And so the first thing we have to do is, in previous lesson, you learned how to find missing sides when given an angle. Now we're going to have to work backwards. And so to do that, we do the inverse because it's the inverse operation. So if I know the side measures, then I am able to find the angle measure by using the inverse function. So before, I had something like the sine of 58 was equal to x over 5. But now I don't know what that sine is. So the inverse function is sine to the negative 1. And then I find that, and on a lot of your calculators, you're going to hit second sine, and then I do 4 divided by 5. So I'm going to hit my second sine, and then I'm going to type 4 divided by 5 and close the parentheses. Sometimes closing the parentheses matters, sometimes it doesn't. And so I get 53.1, and there's the answer. So this is 53.1 degree. You'd have to read the problem to see if it wants you to round to the whole degree or a tenth of a degree. Usually the whole degree will work. Okay, so now I need to do the cosine, the inverse cosine of 7 over 10. So same idea. Inverse cosine or second cosine of 7 divided by 10 is 45.6 degrees, which could be 46 degrees. And then the last one, the inverse tangent of 12 over 11. So second tangent of 12 divided by 11 is 47.49. which we can round to 48. Okay? So if you know the ratios on the sides, then we just use those numbers and do the inverse sine, inverse cosine, and inverse tangent. So the other thing that's going to happen is you're going to have to know how to solve a right triangle. If it says to solve a right triangle, you have to realize that that's asking you to find all the missing side and angle measurements. You can use your trig ratios, so your SOHCAHTOA, and you can actually use the Pythagorean theorem, which is nice because sometimes that's easier and quicker than your SOHCAHTOA. Okay, so here, for number 1, to solve this triangle, I am missing angle C, I am missing the measure of angle D, and I'm missing the length of E to D. And so it doesn't really matter what you do first. I'm going to start with this side first, because if you notice, that's Pythagorean theorem. X squared plus 21 squared equals 75 squared. And so let's do 21 squared, which is 441. I wrote those backwards by mistake. And then 75 squared is 5625. So I minus that on both sides. Oh, I can't write in here. And I get 5184. And then I take the square root. Let's see if it turns out pretty. And it does. It's 72. So I know this is 72. Okay, so now what I'm going to do is I need to find one of the sides. It really doesn't matter what side we do, and we're going to do the same thing we've been doing before. We're going to circle the angle, so I'm going to circle C. I'm going to label my sides. I'm not going to do this 172 just in case I made a mistake there. I'm going to do the two sides I'm given. So this is adjacent and hypotenuse. So I circled, I labeled, and what comes next? That's right, I'm going to pick. So is it your SAW, your CA, or your TOA? And this is A over H. So this is my cosine of my angle, and I don't know what that is, so I'm going to call it C, is equal to adjacent over my hypotenuse. And this is a new problem we haven't done yet. So again, It's just like we did up here, though. When I'm looking for the angle, I do the inverse. So I'm going to do my inverse cosine. Oops, I made 21 divided by 75. And that's going to tell me what the measure of angle C is. So inverse cosine of 21 divided by 75 gives me 73.7. So I'm going to say that angle C is 73. I'm sorry, not 73, but 74, because I rounded up. Now, to find angle D, don't the three angles in a triangle add up to 180? So I can do 74 plus 90, take away from 180. I also can say, well, I know that C and D have to equal 90, so I could just subtract it from 90. And so I get 20, not 26, but 16. Let me just double check my math. I would hate to get it wrong because I do make mistakes sometimes, just like everybody else. Yep, 16. Okay? So it doesn't matter the order you do it. Whoa, what did I do there? It doesn't matter what order you use. You just want to find each of those pieces. Okay? All right, looking at number 2, what I would like you to do is list down what's missing and see if you can find one of those things first. Doesn't matter which one you do, but see if you can list them and find one. And then when you think you have it, go ahead and press play. Okay, so you should have listed that the measure of angle Y was missing, that XZ was missing, and XY is missing. I think the easiest one to find is this first angle, right? Because what do the angles in a triangle add up to? That's correct, they add up to 180. So 180 minus 90 minus that angle of 29 gives me 61. Now, it doesn't matter which of these two sides you want to start with. I'll start with my hypotenuse here. And so I'm circling my 29. I'm labeling my sides. And now I'm going to pick my ratio. Is it your sa, your ka, or your toa when I have opposite and hypotenuse? That's right, it's the sine. So it's going to be the sine of 29 is equal to opposite over hypotenuse. Let's see, sine of 29 is 0.485, so probably 0.49 is equal to 18 over x. And remember, when I have a problem like this, I want to flip it because I don't want x on the bottom. So 1 over 0.49 is equal to x over 18. To get rid of a divide by 18, I'm going to go ahead and times by 18. And so now 18 times 1, which is just 18, divided by 0.49 gives me 36.7. Oops. So that was my ZY, so 36.7. Now you have an option to find XZ. You could do the same process again, or you could use Pythagorean theorem. I'm thinking right now I want to use Pythagorean theorem. I don't want to do any more SOHCAHTOA right now, so let's see what that looks like. So it would be 18 squared plus x squared, because I don't know what this is, that's my question mark, equals 36.7 squared. So 18 squared is 324. 36.7 squared is 1,346.89. You're going to subtract 324 on both sides, and then you're going to take the square root. So you get x squared is equal to 1,022.89. Take the square root of both sides, and so now 1,022.89, and I get 31.98. So I'm going to round that up to 32. And there's your answers. You could have done SOHCAHTOA, and you still would have gotten pretty close to that, if not exactly that. All right, last one. Number 3. I'd like you to try this whole... Oh, there's 2 more. Ooh. All right, try number 3 on your own. See what you can do. Remember to start off by writing down what's missing, and then go from there. Okay, so you should have started off by writing over here what you need. I needed angle A. Oops, not angle C. Well, what am I thinking? Angle, not angle B, but I need angle C because I know what angle B is. Let's fix that. If I can get my mouse to work. And then I need to find AC. Well, AC is the third side of a triangle, which is nice because you just use Pythagorean theorem, which I did here, to get 13.4. Now to find A or C, I'm going to circle one. I'm going to circle this one. And I'm going to label. Again, I'm going to label what was already given. I'm not going to use what I found, because if you make a mistake, you want to make sure that you don't continue that mistake further. You want to be able to start fresh. And so now I circled my angle, I labeled my sides, and now I have to pick from my SOHCAHTOA. And this is TOA. So it's going to be the tan of my angle, A, is equal to opposite over adjacent. And remember, to find that A, you're going to do the inverse tan of 12 divided by 6. And let's see what we get. The inverse tan, or second tan, of 12 divided by 6 is 63.4. So we're just going to keep that at 63. So the measure of angle A is 63. I forgot to fill in the 13.4. And now angle C, you could do another SOHCAHTOA, but really the three angles inside of this wonderful triangle add up to 180. So I can do 180 minus the original 90 minus the 63 I just found, and I get 27. Okay? Hopefully you're getting the handle of it. Try the last one again, and I will just put up answers this next time because I think that you can do this by now. Okay, so here's what the answer is in the end. You get those three answers. I started off by finding what the three angles of a triangle add up to, which I know was 180. So I did 180 minus 90 minus 52 to get 38. The next thing I did was I did my SOHCAHTOA. I circled, labeled, and picked. And I solved this process to get 236. So I rounded that to 2.4. And then lastly, I didn't feel like doing another SOHCAHTOA, so I just did Pythagorean theorem, where I filled in my 2.4, my y, which is the new thing I'm looking for, in 3. And I ended up getting 1.8. So what you're doing, again, is just combining all the processes you've learned. The only real new process you learned today was how to find an angle. And remember, you do second sine or second cosine or second tangent to find that angle. But take your steps one at a time and try not to get overwhelmed. You can do this.